Okay, so here's the final exam review portion of our year or of our video session. This should be fantastic. We're going to start with this, which is the simplest form of this. Well, don't forget, divided by means multiply by the reciprocal. So if I change that to a times, and that's what I would recommend, you got to flip-flop this side. But there's a lot of factoring that's going to go on in the midst of it. So d squared minus 3d. You can't factor that to conjugates, even though this is a squared, this is not. But you do have something in common here. You have a d. So you take out the d, you end up with a d minus 3. Your denominator. That one is the difference of two perfect squares. That can be factored to conjugates. So that'll be a d plus 3 and a d minus 3. Okay? So from that point now, we're going to say times. Now don't forget that this thing here was a divided by, and we changed it to a times. So that d squared is actually a d squared on the bottom. Okay, this actually now has to be factored and plopped up on top. So what two numbers multiply together to get 9 but add together to get negative 6? Well, negative 3 and a negative 3 will do that. Okay, so d minus 3 and a d minus 3 is what that'll factor to become. Now you step back for a moment, you look and see what you have. The d minus 3's cancel. These don't cancel. I've seen people try and do that before. It shouldn't be done because they're next to each other. That just stays it basically remains that. We'll take a look at that in a second. This d cancels with one of these, and so if we clean this up a little bit, this d minus 3 squared is one way of writing that up top, and on the bottom you have this d out in front, it's a d, and a d plus 3 on the bottom. Now it's always a good thing to be able to do something and then look and see what your options are in terms of an answer, and there it is. Okay, the d minus 3 squared over this is the answer. Okay, I guess that's all I can really say about that. That's the answer. Okay, you look on to the next thing here. We're going to do a couple of them in a row. What are the solutions? Well, you look at the square roots, and that should hopefully tip you off to this is going to be a quadratic formula type problem. Okay, so yeah, you could try and factor it, but there's evidence here that says it's not factorable. There's not a single one that says here's the solution. So there's no point even trying to factor. But do your quadratic formula. So negative b, it's a negative 3, plus or minus the square root of negative 3 squared. Now the negative 3 will go away when you square it. Keep track of that. Minus 4 times a times c. Well, your a and your c are both 2, so all over 2 times a. So that's a positive 3 now, plus or minus. Now this is going to be a 9, and this is 4 times 4. It's a minus 16. That's a negative number. Keep track of that. All over 4. Now that automatically tells you that there's going to be an I involved. And so when you look at your options, this one looks good, and so does that one. But if you're forgetting the negative, which some of you do, you're going to miss out on that. You're going to circle the wrong one. So you're going to automatically eliminate those when you see that negative show up inside. Okay. Now, if you forgot about the equation's negative b plus or minus the square root of b squared minus 4ac all over 2a. If you forgot that was a negative and you saw that was a negative, putting a negative inside of a negative should cancel out to become a positive, and that's why your answer should be A, twice in a row. This goes back a little bit. I'm just going to finish the whole side on today. It says find the area of the shaded region. The graph depicts a standard normal distribution with a mean of 0 and a standard deviation of 1. So we're looking at, if you look at breaking it up into chunks, that's 68% right there, right? And we're only going to 3. So one other thing you may want to consider is, you know, this and this portion and that portion make up, you know, most of this side. One thing you can do is say is this is just short of 50%. Okay, 50%. I say it's just short because remember there's a small portion on the outskirts there that basically are whatever's remaining. And so if you kind of said, okay, that's just a little bit less than 50% because 3 standard deviations is not 100% of the data. And if you really do the math and remember that 99.7% is within 3 standard deviations, then half of that 0.3% is what's out here. It's 0.15%. Now let's pretend that we don't even know that and we don't even bother thinking about that. This is still really close to 50% because it's still half of it. And so half of 68 would be the rest of this side, which would be 34%. So basically, if you add these two together, you got 84%. But if you're remembering that it's just a little bit less than 84% because of the additional that's left outside here, that number right there is the one that's just a little bit less than 84%. So you don't even have to really remember that specific number, aside from the fact that it's most of the data falls within 3 standard deviations. So very, very little is going to fall outside. Okay. A again, by the way. And finally, on this page, in the year 2007, a company started with 50 employees. The company's not doing well and decreases the number of employees by 8% each year. So your initial value is the 50. Your decrease of 8% means you're left with 92%. Think of it this way. If you missed 8% on a test, you got a 92. That's a good thing. But it's still less than 100%. So this number should be less than 1. That shows the decrease. In 2007, this started. Which expression below calculates how many employees the company will have in the year 2014? Well, 14 is 7 years after that. So if I raise that to the 7th power, that should get us there. That would be answer C.